Alright, so we've seen that vanishing gradient is related to the fact that we use sigmoid activation. So then people invented the ReLU activation, and we've used ReLU in our coding exercises. But now it will give you a better idea on how we went from sigmoid to using ReLU now. Sigmoid is still used, at the end for a binary classifier, but especially for all the hidden layers it will be ReLU. And this is ReLU, we've seen it. The way it works is that the ReLU of Z is 0 when Z is negative, and is equal to Z when Z is positive. Yeah? Now if you take the derivative, you're going to get this. Yeah, you will have a constant gradient of 1. Yeah, the derivative of Z with respect to Z is 1. So, so let me write this here. ReLU of Z prime, yeah, equals 0 when Z is negative, 1 when Z is positive, and not defined when Z is 0. Yeah? So here you have a discontinuity, so the derivative in Z is 0 is not defined. Yeah? Alright, so what does it now mean? We still look at the same network here. Yeah? But now these derivatives, instead of being from 0 to 0.25, these derivatives are going to be, all 1. Yeah? So you have 1, 1, and 1. For Z is positive. But there is a risk that Z is negative. And if Z is negative, you can have as many 1s as you want. So when you have 1, 0, you have a problem, but because the outcome will be 0. And this we call a dead neuron. Yeah, and that's basically not what you want to have. Yeah? Because here again the learning will stop. So what have people done? Well, they said, okay, let me put a small negative slope here. Yeah? And in this case, this one will become 0.01 times Z if Z is negative. Yeah? And this is how you avoid getting a 0 here. I've not really seen it used. So in all the exercises we do, we just take ReLU. I've never seen that we have to use this scenario here. This is called leaky ReLU. I've not seen it used. But it's just remember that you may find some alternatives here. And so that's it. That's how we got from sigmoid to ReLU.